I'm going to be solving the 2007 AMC 10A problem 24. Let's read through the problem. It says, circles centered at A and B each have radius 2 as shown. Point O is the midpoint of segment AB, and OA equals 2 root 2. Segments OC and OD are tangent to the circles centered at A and B, respectively, and EF is a common tangent. What is the area of the shaded region ECODF? So we want to find the area of this region right over here. So the first step that I did in this problem was I connected EA, so I had segment EA, and I connected BF. Next, I connected AC, and then I connected BD, or DB. So one way to do this problem is to find out the area of rectangle EABF and subtract out all the areas that aren't shaded. So let's see what happens when we do that. The question says that the radius of each of the circles is 2, so EA is 2, and BF is also 2. And it also says that segments OA is equal to 2 root 2, and also that means that segment OB is also 2 root 2 because the circles are congruent to each other. So we can say that segment AB is 4 root 2. Now, we can say that the area of EABF is going to be equal to 8 root 2. Now, the next step in this problem is to subtract whichever regions we don't want. So, namely, it's going to be the the part of the circle bounded by the arc EC, so like region EAC. Then in the other circle, it's going to be DBF. And then it's going to be these two small triangles, ACO and BDO. So first, let's find the area of the two triangles. And by the two triangles, I mean this one and this one. So we know that AC is 2. And we also know that AO is 2 root 2. Right here is 2 root 2. And in fact, instead of 4 root 2, I'm going to write each of those segments as 2 root 2. So this means that it's a right triangle because any tangent to a circle is perpendicular to the radius that intersects it. And so this is also 2, and this is also 2. So the area of triangle ACO is going to be 2. It's going to be 2 times 2 over 2, which is equal to 2. And this is also going to be the area of triangle BDO. So 2 plus 2 is 4. So from this total right here, we're going to have to subtract 4. So we're going to have to subtract 4. And then I'm going to shade these in so we know that we've already used them up, or we've already found the areas of them. Next, we have to find the areas of these arcs. So we know that we know that each of these arcs, so BDF, it's going to be an eighth of the circle because it's going to be half of 1/4 of the circle. And so, since it's half of 1/4 of the circle, it's going to be an eighth of the circle. So it's going to give us 1/8, so 1 over 8 times pi r squared. Pi r squared is going to be the area of the circle, and the circle has radius 2. So it's going to be 1 over 8 times pi times 4, which is equal to 4 pi over 8, which equals pi over 2. Now this is just for one of the arcs. So to find the area of the other one, it's going to be the same thing. It's going to be pi over 2 as well. So pi over 2 plus pi over 2 is equal to pi. And once again, the region, I just counted these regions right here. This one and this one. And so those are pi. And so we also have to subtract that from the total. So it's going to be 8 root 2 minus 4 minus pi. So in summary, what we did was we found the area of rectangle EABF. We subtracted off right triangles, the two right triangles we had, which were this and this. Then we subtracted off these two little regions of the circle right here. And so that gives us our total 8 root 2 minus 4 minus pi. And so the answer is B.